Hello, this is Tony from GreatIdeaz, and the purpose of this video is to cover some of the code generation technology we use to optimize the search and read processes within trellispark. So what we've done is we have created a test code generation functionality, and if I go into here, I've created three forms. One form that's going to create a lookup table that uses all of the fields within the table, one form that has no lookup capability at all, and then one form that has a partial lookup. So instead of looking up all of the fields, it's going to look up a specific tagged field. So let's have a look at the definition of these tables. So let's start with the full lookup. And you can see that we have a concept. It's called full lookup. The data model has got four fields, F1 through F4. And if I go to the optimization tab, you can see that I've set the add lookup table to include all fields and the rebuild lookup table for this code generation as yes. And if I look here, I can see I've got F1 through F4 all set up as strings. And if I go and have a look at one of these field definitions, you can see that I just have a string, it's F1 and so on. And I've not bothered to have to tag whether this is a tag field for the lookup or not. So here is the initial data set. It's full lookup, four fields, optimization has been set to all fields, and rebuild lookup table is yes. Once you already have the lookup tables created, you can set the rebuild lookup table to no, and then the create tables won't be included in the scripts that you generate. So let's now have a look at the script as it relates to the full lookup table. First of all, we're going to have to make triggers on the lookup table so that when I add a row to either my full lookup or partial lookup, that it adds the row into the lookup table. So essentially what we're doing to start off with is we're auto-generating a lookup delete and a lookup save. So whenever I add a row, I'm going to basically trigger a combination of saves and deletes. So if I'm executing a delete, then it's just going to execute the delete functionality, and insert will just execute the save functionality, and an update will execute a mixture of delete followed by save. So these are basically put on the lookup triggers. And if I look at the full lookup, you see that the full lookup is creating a table LU, prefix, and full lookup. It's got all of my standard instance table columns, and then it's pulled across all of my string fields. So without me having to tag individual strings, it's grabbed everything. Okay. What it's doing now is it's putting a primary key on my lookup table using the instance GUID of the record. And it also creates basically a set of indexes. So, basically looking at the hierarchy, the parent GUIDs and the instance names, it gives us different ways of actually indexing that lookup table just by default so that we can optimize the searches. Now, obviously, once you have created the lookup table, you can add your own clustered and non-clustered indexes to it. So as well as creating the lookup table, what we're also going to generate is a couple of views. So one of the views that we generate is going to pull all four fields out of our lookup table. And this essentially just denormalizes the XML element string so that you can do a select on VW underscore ZGC underscore full lookup and execute a select on F1, F2, F3 directly rather than having to decompose the element strings yourself. So this makes it a little bit easier to write queries that you're going to use to actually query the information from the lookup table for using the view. In the case of using the full lookup, you typically wouldn't do this. You'd actually just go straight to the VW ZGC full lookup table and just pull the information directly out of there. So in the case of a full lookup, this view is typically redundant. The other thing that we do is we also create you a view that denormalizes the information from the history tables. So again, this lookup table is enabling you to execute a query against the history. And this time it's going to pull out every single version of the instance record that's been stored in the history table. Okay, so next we have a get stored procedure. Again, we're using the prefix table name functionality, and this is typically used by child lists within the application. So depending on how we set up the access rights, we are going to do a lookup of the information in the lookup table in this particular case. So if we go here, we can see that we're using the LU lookup table to actually pull the information. So instead of going to the view, because we have a lookup table, we're going to go to the lookup instead. And as you can see, we're making a check first to make sure that the session is valid, and then we're checking that the user has access to an ancestor of this data so that we're doing a security check to make sure that the user can actually see the records being returned. If we were doing the validation on an instance level, then this would actually be replaced with an instance check here on the select so that we would only return records that the user actually has access to. So in the case of the get stored procedures that we're using to put data into the database, we are using the lookup table, and that's the key takeaway here. Okay, so a get will use the lookup table if a lookup table is available. And then these are the lookup table, delete and insert. So you can see that if we're calling the delete stored procedure as part of the trigger, all we're doing is removing the record from the lookup table. If we're doing an insert, then we're going to basically pull all fields and insert them into the lookup table. Now, this is something that is generated by default, and for larger lookup tables, you may want to remove. So for example, if you are just regenerating a lookup table with like 10 rows, then great. This will basically drop, recreate, reindex the lookup table, update all of the trigger code, and then we'll just go through and cause the 10 rows currently for that lookup table to be refreshed and reloaded into the lookup table. And that might be great if you're just refreshing small lookup tables. On the other hand, if you're going to refresh a lookup table that's got 10 million, 100 million, a billion rows in it, then you probably don't want to do it this way, and you probably won't be rebuilding the lookup table on a instance to instance basis. So as you actually change the fields in the lookup table, you probably will not want to actually rebuild and regenerate the lookup tables. So again, this is something that you might want to turn off, and a change that you might want to make in terms of how you deal with lookup tables. So during your development and testing phase, where your tables are relatively small, this approach is great for generating those base lookup tables and rebuilding them every time you execute a change to your data model. Once you're in production, you probably want to suppress the automatic rebuild of lookup tables and the repopulation of lookup tables. Okay, so now let's go and have a look at the other extreme. So what happens if I say, I don't want a lookup table? How do I do that? Well, here I've still got my 4 fields, and if I look at optimization, I've said add lookup table equals no, and rebuild lookup table is no. And what does that do to my code generation phase? Well, here you can see that I have no code to rebuild the lookup table. There is no lookup table to build. So all I'm going to do here is I'm going to create my view that denormalizes and strips out the XML in the instances table. And here I have the equivalent code that will shred the XML from the instance history table. And here is my store procedure that I would use on a child list by default to get information out of my table. Now, this time I don't have a lookup table. So instead of using the LU underscore ZGC underscore no lookup, you'll note that this is using the view directly. So all of this stuff stays the same. We still need to validate that the user has a real session. We still need to validate that the user has some form of access to this information. And in this particular case, we are not using an optimized lookup table. It does not exist. Okay, so that's the two extremes. On the one hand, we're creating stored procedures that access the lookup table. We're creating the lookup table. We're indexing the lookup table. We're refreshing the lookup table. In this case, with no lookup, then there is no lookup table. Only the view exists. Now let's have a look at what a partial lookup table might look like. So if we go back here and we open the partial lookup table, again, we set the same basic fields, F1 through F4. Our optimization is now set to look for tagged fields only, and we're going to rebuild the lookup table. Now in this particular case, if I look at this F1 field, you'll see that I've set the lookup field as tagged as yes. So this is basically going to mean that my F1 field will end up in my partial lookup table. If I go and have a look at any of the other fields, like F2, for example, and I scroll down here, you'll see that the lookup field has not been set. By default, it will take no. Okay, so either no or blank means the same thing. The lookup field will not be added to the partial lookup table. So let's look at what that looks like in code now. So here, for the partial lookup, then you'll note that we're only pulling the F1 field. So on the full lookup, we pulled F1 through F4. On partial lookup, the only field in the partial lookup table that was tagged as requiring to be added to the lookup table was F1. Again, we're going to generate our default indexes. Now, our view is still going to pull F1 through F4, because if we're doing a query, even though we're not going to add F2 through F4 to our lookup field, we still want to be able to denormalize the F2 to F4 values. So our lookup history table is also working the same way. It's denormalizing all of the available fields from the history table. Now in this case, our partial lookup table is actually going to use the LU ZGC partial lookup table. Now the select star from here is obviously only going to pull F1. So F2, 3, and 4 are not in the partial lookup table, and so would not be available as a select star. So this is an example where you might have a concept with, say, 100 rows in it. Okay, and you only ever use 1 or 2 or 5 rows whenever you do a search or when you add that concept into a child list. So you don't need, the full 100 columns from that table. You only need the columns that you ever use for searching or displaying inside these child lists. So you might restrict that from 100 fields down to 3 fields or 5 fields. So one of the really cool ideas with the partial lookup tables is you only really need to look up and index the fields that you actually search on or display in child lists. The additional fields you don't need to worry about. And this really helps as you get into development and you're constantly adding additional fields into the concept. But those additional fields are just extra data that's available when you're editing a particular record. It's not used in the search or the listing processes. And so I don't necessarily need to rebuild my lookup table every time I add extra fields. Okay, so this again, from a performance perspective, is better because you've got less data to move into the lookup table, you've got less data to index, it's taking up less room, it's actually faster to execute, and you're not rebuilding it as frequently because you're not attempting to capture every single field that's available inside the concept. So as you might expect, we still need to remove elements from a partial lookup table as we go through a delete or an update process. And here on the insert, you can see that the only thing I'm actually inserting into my partial lookup is the F1 field that I'm actually extracting. So fields F2, F3, F4 are not being moved into the partial lookup table as part of the save. And again, at the end of rebuilding a lookup table, we have this optional refresh lookup table. And again, great for small tables during development. Really recommend that you comment this out and use another mechanism to refresh lookup tables in your production environment. You may end up having to come back to something like this to basically say, well, okay, I'm going to truncate this table and then refresh all of the rows. Particularly if you're adding additional fields into a partial lookup table or a full lookup table. But as I say, it's going to go through and refresh every single row in that lookup table. And as I say, the small tables, great. For really big tables, that might take a significant amount of time. So other options might be more appropriate depending on your implementation. So that's a quick summary of the code generation functionality. What happens during code generation is that you will go to the functionality. You will go here to generate SQL. Once you click this function, it will go away and generate SQL. The code generation will be added down here in your attached file. So here is the file that we've just been looking at. If you open this attached file, you can see here that we have a file. I can now download that and open that file, and that file is the thing that we opened and we've been reviewing here. Okay, so the code generation is essentially going to look at your existing data model if it exists at the point where it was generated. It is then going to basically create all of these scripts. These scripts are then available for your DBA to review and to sanity check, and then decide which ones they want to apply in which environments. So a good way is obviously to generate the script and then copy it from dev and then use the same script in your QA and then potentially into your production environments. The one thing that you would need to decide as you're doing that is whether or not you're rebuilding the lookup tables and what strategy that you are going to use to repopulate any changed lookup tables. We've had clients where they wanted to do a full lookup table on every single concept, and we've had clients where they've hardly used any lookup tables at all. There might be 100 concepts in their data model, but they only really needed to put lookup tables on 10 of those concepts, and within those 10 concepts, they only needed to look up maybe 20-30% of the fields. So it's up to you to choose between the extremes of no lookup tables, full lookup tables on every concept, and then somewhere in the middle that makes sense for your particular implementation. There's no point putting lookup tables on concepts that you're never searching or that you're not putting in child lists where you need a restricted set of rows. And we're going to look at how to integrate the tables and stored procedures created by the code generation framework for your lookup tables into the underlying triggers that will fire whenever you make a change to an instance record in the instances table. So let's just quickly review what we have. We have a functionality called test code generation. Inside there, we have defined 3 forms: a full lookup, a no lookup, and a partial lookup. And we have gone through and executed SQL code generation, and we have generated a code generation script that we have then downloaded, and we are in the process of applying to our database. So I'm going to make this change into my dev database. And so the first time I load this script into my dev database, these procedures and so on aren't going to be there. So essentially what's going to happen is that the database is going to raise a bunch of errors saying, hey, you haven't got one of these, you can't delete it, and now you can because it exists. So now if I execute this script, what we'll see is a whole bunch of error messages saying that these functions don't exist yet because it doesn't exist or you don't have permission. If I tell it to execute it again, I'm expecting to get a clean run. Okay, so at this point I have a clean run of the data model, and it's gone through and it's created all of these stored procedures and everything else. So at this point, everything is now in the database ready to go. So what I need to do now is I need to go into my database, and I need to go into my programmability and my tables, and let's have a look and see what we need to update. So if we go and have a look at the instances table, we see that there is a trigger on the instances table called maintain lookups. So if we go and have a look at that trigger, what this is doing is it's doing potentially a bunch of different things. It's going to check when we insert data into the table. It's going to run through two cursors. First of all, it's going to go through a deleted records cursor, and then it's going through an inserted records cursor. What we want to do is essentially call this lookup delete stored procedure every time we're removing. So if we're deleting a record, we're going to call this, and if we're updating a record, we will call this, followed by a call to our lookup insert. Okay, as well as doing the basic check for maintaining the lookup tables, this is also essentially going to cascade any changes of our last updated parent field. Potentially, we could use this trigger to write information to our messages table and anything else that we want to do as a basic function on a change to the instances table. But for the purposes of this presentation, what we're interested in is lookup insert and lookup delete. So if we go to these stored procedures, okay, so let's pull up the lookup delete and lookup insert. Okay, so this is basically taken from our current dev environment, so we're going to have a whole bunch of things in here that you're not going to need to worry about. But essentially what's happening here is we execute the lookup delete, we want to link in the new lookup delete functionality we've introduced in our code here. So if we go and have a look here, you'll find that there is a lookup delete and a lookup insert here called ZI delete ZGC. So this is the prefix of our new functionality, and lookup insert, and we're doing the delete here, and here we've got the lookup save. So essentially what we want to do inside our delete and our save stored procedures is add our new functionality into the mix. So what we're going to do is we're just going to add, in this case, ZC, and this will now link our code generation into the lookup delete trigger, and the same here for the save function, EG. And if I execute these two functions, what I've now done is I've integrated my new functionality and all of the maintenance of the lookup tables into the core insert trigger on maintain tables. So if you remember, if we were on the maintain lookups stored proc and trigger here, what this is going to do is this trigger is going to call lookup delete. Lookup delete, as part of its processing, is going to say, hey, do I need to delete the instance from the lookup tables associated with this concept, and ditto here for the save. Obviously, in your solution, you will have far fewer lookup instance triggers, because we have essentially all of our development functionality and a whole bunch of other stuff in here as well. So your tables initially will be much slimmer. But what this is going to do is that every time we insert a new record, it will take an extra couple of microseconds where it basically decides whether or not we need to update a lookup table. If we are going to update the lookup table, it will shred the instance data that's been presented and insert it into the lookup table and maintain the indexes. So this is a little bit of time every time we insert or update a record, but what this means is that we then have optimized lookup tables and indexes available whenever we need to search through a set of records to find particular data. And it also means that if we're executing a child list on a form, that we can essentially get the values for the child list directly from the lookup tables as well. So this is all about improving the performance of our searching and listing functionality.
To learn more about GreatIdeaz products and solutions, visit GreatIdeaz.com. That's GreatIdeaz with a Z.com. Thanks.